Hello and welcome to another AI Shepherd video, where we'll be diving deep into another AI tool. Now here's the deal. Today I woke up and I wanted to get rich overnight, because who doesn't? And what better way to do that if not by crypto? Now, luckily, I remembered that I built myself an AI crypto agent that will be doing the thinking for me and help me figure out what to invest in without losing time and hair figuring out the best moves to make. Now, I may not know much about crypto, but I do know about Bitcoin and how it made a bunch of people on the internet rich in the last decade. Imagine explaining that to your blacksmith ancestors. So to get started, let's see how Bitcoin is doing now. Alright, let's see the overnight richness potential of Bitcoin now. We'll be analyzing Bitcoin prices from last month. Okay, here we have our Bitcoin price analysis from the 14th of October to the 14th of November, the last 30 days. And according to the chart, it seems like Bitcoin has been in decline for the past 30 days. But I still can't afford one now. But hey, trade-in basics are buy low, sell high, right? Maybe this is a good time to buy. But just to be sure, let's ask AI for a trade signal. Let's ask it if it's a good time to buy now. So give me a trade signal for Bitcoin. Okay, we have our trade signal here. Our AI agent used three technical indicators to provide us with this trade signal. Each one of these technical indicators come with a chart and an interpretation. Now we'll go straight to the key takeaway, as it'll take too long to go through the whole analysis. So the overall sentiment leans towards caution with a blend of potential bullish and bearish signals in the market. So caution is what our AI agent suggests. In this case, it seems like the market is a bit too uncertain and it isn't clear yet whether it'll be bullish or continue to be bearish. Now, I'm curious what else this talking website can do. How about we compare Ethereum and Bitcoin? See which one dipped more recently? Alright, here we have our comparison. Since we didn't provide a specific time frame, it just defaults to last 30 days. We see the price change for Bitcoin is 13,000, and the percentage change, relatively, is almost 12% of its value gone. Now for Ethereum, it's almost 22% of its value gone. So according to the price change percentage of both coins, Ethereum has relatively lost more of its value than Bitcoin. We also have a chart that shows the price evolution of both coins in the last 30 days for all the visual learners out there. Now, we haven't gotten that deep into the analysis provided by the agent, as that would take too long, but you can try this out yourself on my website and take the time to read the analysis provided. So far, we've seen four of the many things this crypto AI agent can do: analyze, predict, compare, and visualize, all automatically. Pretty neat, isn't it? Alright, before you think I just made a talking website that can guess crypto prices, let me assure you, there's a little more science behind this madness. So, the AI Shepherd presents, drumroll please, AI Crypto Agent. You can check it out later at aishepherd.dev, but first, let's see what this thing's really about. So, the goal here is to simplify and automate crypto analysis for both enthusiasts and traders. And we can do this by referring to the Trinity. Speed, because every second counts. Reliability, because hallucinating financial advice is a lawsuit waiting to happen. And actionable outputs, because if AI tells you something you can't act on, it's just poetry. So then we move into the problem. Now, if you've ever tried to keep up with crypto news, you know it's chaos. You wake up and half your portfolio's gone because someone on X posted a frog meme. That's the enthusiast side. And traders, you folks have it worse. Every second counts, but your data is scattered across 10 tabs, 5 APIs, and a single tab of Lucky Charms. So, between hype and misinformation and overanalysis, most people end up either missing opportunities or second guessing themselves. That's the problem we're solving. Alright, so how do we fix that? This is where the agent comes in. Here we have the diagram. The first part is set in Flask. This is where we type the question or the query, and then we submit it. Once it is submitted, it is sent to the AI agent backend that processes it. Now the AI agent picks the right tools to answer with, gets the output from these tools, and then proceeds to answer the query. Once all is done, the query is sent back to Flask and then rendered along with the shards generated in HTML. This little brain here, this is the architecture of the AI crypto agent. Think of it as a crypto-obsessed intern who reads, compares, and reports back with actual logic. It has multiple nodes that do specific jobs like analyzing, comparing, collecting metadata. All these nodes work together like a relay team to produce that fast, grounded answer you saw earlier. All right. At the core of our AI agent, we have a LangGraph. Think of it as the agent's workflow brain. It starts by figuring out which tools to run, it executes them, then notes what it used through a metadata collector, and finally synthesizes everything into one smart answer. In short, it plans, works, takes notes, and explains. No breaks, no confusion, just clean logic start to finish. Now, let's look at what powers this graph behind the scene, the agent state and the graph builder. And as we've said before, at the core of all this is LangGraph, basically the wiring that connects each part of the agent's brain. Every agent starts with two key ingredients, an agent state, the agent's memory, and the graph builder, the function that defines how everything flows together. They let me decide how data moves, which tool gets called, and what comes next. Now let me show you what the code looks like. And don't worry, it's less complicated than the crypto market. Now this is the agent state. It's basically the agent's notepad, keeping track of everything happening in the workflow. It stores the final prompt sent to the LLM, the tool prompt used to decide which tools to run, the messages exchanged during the reasoning, and the tools that were actually used. Think of it as the agent's short-term memory, organized, structured, and ready for the next move. Okay, now let's take a look at how we can use the agent state to build the graph. Now we'll be moving on to some more code when we'll see the graph build function. Here's where everything comes together. The build graph function defines how the entire AI agent operates. First, it initializes a tool node which wraps all the available tools the agent can use. Then it creates a state graph, which is basically the logic map of how the AI processes a user's query. We then add several nodes. We have the tool selection LLM, where the AI agent decides what tools to use. Then we have the tools node, where these tools are called. Then we have the metadata collection, which gathers results and context. Then the debugger that checks for errors or inconsistencies. And then finally, we have the AI crypto analyst, where the final synthesis and answer happen. Finally, we define the flow, the relationship between all the nodes. It starts with the tool selection, goes through each step, and ends with the AI's final response. So in short, this is the brain wiring of how the agent works. Okay, now that we've seen the function that builds the graph for our AI agent, we'll be going back to the LangGraph, and now we'll be taking a deeper look at each node of our graph. This is the function that launches the LangGraph and starts the processing chain. It's a for loop that sends the first message, which is the user query. And this first message gets added to the messages key in the agent state. After the first iteration, we set everything in motion by simply sending over the user query. This iteration continues until the final answer is ready. Now let's take a look at the tool selection. This is the decision maker of our AI agent. This is the function where the tools to be used to answer the user query are chosen. First, we get our tool prompt set up with some placeholders. The prompt is defined as a simple string in another Python file for our organization purposes. Then we set up an LLM instance, which basically opens the AI API call and bind a list of functions or tools that the AI agent has access to. After some simple login, we then call the OpenAI API to select any tools needed to answer the user query. Finally, we return the message and a tool prompt so they can be added to the agent state. Now let's take a look at an example of a tool function. Now let's take a look at one of the most important tools used by the agent, get crypto price range. This tool is called almost every time the AI needs real data. It fetches the price, market cap, and trading volume for any supported cryptocurrency between two given dates. First, it converts the date strings into proper Python date times, making sure the input is clean and consistent by using .replace and .strip. Then, it runs a database query that fetches all matching records from our crypto market data table. Once it gets the results, it builds several lists, prices, market caps, volumes, and dates. And then it calculates the price summary, which includes the minimum, maximum, average, and even the percentage change over time. Finally, it returns everything as a structured dictionary ready to be used by the other tools or by the AI directly. So you can think of this as the data engine. It powers almost every chart, comparison, and insight that the AI produces. Now we get to the tool execution part. Now to run the chosen tools, we use a pre-built class that we import from LangGraph. This is it. This takes the tools selected by the LLM and runs them using the parameters that were also decided by the LLM based on the tool's description or docstring. Once the tools are called, the output is stored in the messages key of our agent state. Next, let's take a look at the metadata collector. This guy here is our snitch. It tells us about what the AI agent is doing with the tools it has access to. In its current state, it's pretty simple. It reports what tools were used and their given parameters. They are then added to the used tools key of our agent state. Now let's take a look at the final node. This is where we get the agent's final answer for the query. Here, we're looking at the first part of it. We collect all the agent state's messages we have gathered so far. Then, for login purposes, we pull only the names of the tools used from the agent state, and then we just log them. Now for part 2, first we run a check to see if the AI decided to generate any charts. For technical analysis, we log this check. Then, this is where we put all the agent state messages into the final prompt to tell the LLM to answer the user query using the content of these messages, as they contain the result of all the tools used so far. After some exception handling, we add the final response to the messages key of our agent state along with the final prompt to its corresponding key. Now let's take a look at how this process ends by pulling the last message from the messages key of our agent state class. We go back to the start. The final iteration of our loop puts the content of the AI's answer into this variable called last message. And then we return this as the result of our stream function right here. After this, Flask takes over again. But before the Flask part, let's take a quick look at this monster. This is a more production-ready, less error-prone, and more accurate LangGraph for the same AI agent. It's more complicated, but for good reason, I swear. It gives more control over every part of our agent. Once we start, the first node we come across is called Relevance Guard. This part decides whether the user query has anything to do with crypto. Now here we have two conditional paths. One is for when the query is crypto relevant, and the other is for when it isn't. If it is crypto relevant, we move to the coin guard, where we check if the crypto coin that the query mentions is supported by our system. If it isn't, we head straight to the final node and tell the user that the requested coin isn't supported. If it is, we go to the classifier. This is also the node where we go for even when the query is not crypto relevant. This is to see if the AI agent can answer the question anyway. In the classifier node, the AI agent tries to define the query with one or more categories. Each category has access to specific tools, has specific metadata collection, has specific AI calls, and prompts. Once the category or categories are defined, the agent picks the tools required for the job, gathers the data, and then gets to work. So here we see the different paths for each category. We have portfolio, performance, other, fundamental, and comparison. So for example, we follow the fundamental category. Here we decide what tools to use. Here we gather the metadata on what tools we're going to use, and then here we execute the tools. Once the job is done, we get the final answer at the AI Crypto Analyst node. Now we process one category at a time. So after the logger node, we always run a check to see if there's another category to run so we can answer the query properly. This takes us back to the classifier node, which goes through the corresponding path for any remaining categories. Once there's no more categories left to run, we jump out of the graph and into Flask. Now, that was a lot to unpack, wasn't it? I was paying attention. Were you? Well, there's a little bit more left. Let's take a look at Flask. The Flask part is pretty straightforward. We type our question or query in the text box and then hit submit. This sends our query to Flask, and then Flask calls the stream method of our AI agent to get it to work on an answer. Once the answer is ready, we render it in HTML along with any generated charts. Now we get to see how Flask connects the backend to the front end through this route /crypto agent. The first thing we get is we collect our form, and then once the form is submitted, we check this condition and we get the user query. We send the user query to our crypto AI agent through the stream method, and we pass the user query as a parameter. Then we store the AI agent's answer here and any generated charts here as well. Then we keep the AI agent's answer in the session so we don't lose it on page reload. And if there's any shards, we also save them, but in a different manner, seeing as the shards generated by Plotly are too large to save in Flask sessions. So we save them as JSONs in a temporary folder using this custom function. Then after a bit of thorough exception handling, we redirect to the same page where we show the result. And of course, the result is shown through the render template by loading in the HTML of the page, as well as the form, and we check if there's any saved answers to show. That was a lot simpler than the first part, wasn't it? If only that's all it took. Now let's take a look at the traceability and the metrics. Now for the metrics. This part is important to indicate for any AI solution. It's basically a resume for your AI agent. Our crypto AI agent has a typical latency of 5 to 20 seconds. This depends on how many tools are used as there are multiple OpenAI API calls. The cost per query is very low since the AI system is made very cost efficient by using small models. And instead of calling an API for price data on every query, we store price data in a database. After calling it through an API once a day to keep it updated, this avoids unnecessary API costs. The accuracy of the AI agent is around 80% for the tests that I have done so far. The price data is never hallucinated and is pulled from reliable sources in crypto coin price estimates. The AI agent is told to only use the provided price data to provide its analysis, and it follows expert guidelines indicated in the prompt to provide the analysis. Now for maintainability, this system is easy to maintain. This is due to robust exception handling and login. Whenever we have an undesirable effect, the login allows us to trace it back to a specific node, so you don't have to pull your hair looking for where you forgot to close parentheses. Now let's talk about hosting options. If you're using Flask, you can host the full web app version of the AI crypto agent on platforms like Render, Railway, or Heroku. This setup is great for interactive dashboards or when you want users to submit queries directly through a web interface. The entire code for this AI agent, along with its Flask, is available on GitHub if you would like to clone it. On the other hand, if you want just the backend logic, the AI agent itself, you can deploy it without Flask using Fast API, Gradio, or even as a command line tool. These lighter setups can run on AWS Lambda, Google Cloud Run, or inside a Docker container, perfect for automation and system integration. Okay, now let's take a look at some more specific uses of this AI agent. You can ask for a specific technical indicator and even specify the parameter you want for it. Alright, here we asked for an SMA chart with a roll-in window of 10, and it gave us exactly what we asked for. You can also compare up to 4 cryptos using technical indicators as well. Here we compared Ethereum, Bitcoin, Avalanche, and Dogecoin, and we asked for a Bollinger Band indicator for each one. If we scroll down below, we see the comparison charts. We have 6 of them, comparing 2 coins at a time, and then a Bollinger Bands analysis for each coin that we mentioned. And then if we scroll back up and go to the key takeaway, the takeaway tells us which of the 4 cryptos is more likely to have a reversal. And here we use 2 tools to get the agent to explain what happened to Bitcoin prices in the last 30 days. We used a market volume chart and we told it to get some news articles. And here we can see our answer along with a volume chart. And that was it. We've reached the end. This is where we part, but before we do that, keep in mind that the code for this website, everything, backend, front end, is included in a GitHub link in the description. You can also try the full version, or rather the more production ready version on my website. The link is in the description. It's free as well. And there is a subscribe button, a like button, and a bell button. If you click all 3, you'll get more content like this. Bye bye.